with the real video, ideally there's going to be sound with this, so I am sorry for sending out a video without any directions, which is kind of confusing. So yesterday we talked about how electrons, due to their instability within atoms, help form bonds. Now we talked about the structure of the atom, where there are positively charged protons in the nucleus, which attract electrons, and those electrons repel each other. So we have a couple different components to think about when it comes to the atomic structure. The first is, if we have our nucleus here, we're going to only be able to fit a few electrons in the first orbital. And this is because there's not a lot of space, and that this electron and this electron each have a repulsion to one another. So they're always going to be fighting against each other, but they're also going to be positively attracted to the positively charged nucleus. So we usually describe these electrons as having low potential energy. They don't have a lot of energy because they're so close to the nucleus and they occupy such a small space. They're always going to be repulsed by the other electron. So there's two factors as to why this electron isn't going to have a lot of energy. The second thing that really is important is that as you get further away from the nucleus, electrons tend to have more energy. And the reason why is that they're at a further distance from the positively charged nucleus, so they feel a less powerful attraction to that positive charge, but also they occupy a far greater space. Think about this as a sphere, which means that the repulsion of one electron to another is going to be weaker. And the fewer electrons you have in this outer shell, the more energy and the more space they're going to be occupying, which causes some instability, some reactivity within those atoms before they form a bond. And we sort of saw that with the kindergarten cop, where without a positively charged nucleus nearby, or in a space with lots of freedom, the electrons, the kindergartners, sort of ran wild. So the way that you're able to bring a atom to become more stable is maybe introduce another nucleus with another atom that can also attract these electrons or fill in the outer shell. Which brings us to covalent bonds. So covalent bonds are where one atom and another atom are going to co-share electrons, and that's going to do a couple things with the structure and stability of atoms. So if I delete this, let's see if I can delete this easily. Nope, I'm not going to be able to delete any of that. So I'm going to just go over H2O here, which is a covalent bond. So I have hydrogen, and hydrogen has a positive 1 charge in its nucleus and it has 1 electron. We can fit another electron in here, so because this electron is free, it has a lot of energy. It's unstable because there's not a second electron here that is causing it to be more stable with less space. And the same is true for another hydrogen atom with 1 electron. Now oxygen has a full inner shell. It has 2 electrons, and it has 1, 2, 3, 4, 5, and 6 electrons in the outer shell. And we know that because there's 8 protons in the nucleus. That's its atomic number, which means that it must have 8 electrons. So a covalent bond is going to be where oxygen shares one of its electrons with hydrogen, and hydrogen is going to share one of its electrons with oxygen. So suddenly we now have that 7th electron, and suddenly hydrogen has its 2nd electron. Now these 2 electrons are going to add space into this outer shell, meaning that we're suddenly going to have the 7th electron sometimes exist over here, which means the repulsion between electrons increases, which means their energy goes down. Furthermore, because we're introducing another positively charged nucleus into the atom, suddenly these electrons are going to have two different positively charged regions in the molecule, meaning that their energy is also going to go down. We're bringing that stability up. And then we can do a second covalent bond where this electron from oxygen is going to be shared with hydrogen, and hydrogen is going to share its electron with oxygen, bringing us to 8. And that's the maximum amount of electrons we can have in this outer shell. If we tried to introduce a 9th, it would be repulsed because there was not enough space for all of those negatively charged electrons to occupy that space. So when we get to Molview, we're going to be using these molecules, these atoms, to be forming covalently bonded molecules. So carbon and silicon can make 4 bonds. They need 4 electrons. Nitrogen can make 3 bonds. It needs 3 electrons. Oxygen needs 2, fluorine needs 1, and hydrogen also needs 1, but it can only fit 2 in its outer shell. So when we actually get to Molview and try to form these bonds, all you're trying to do is create covalently bound molecules that are stable with different types of bonds. So I'm going to start with carbon. Carbon, looking at my periodic table, can make 1, 2, 3, 4 bonds. It needs 4 electrons. So that's a good thing to think about. Carbon needs 4, but can also make 4. 4 plus 4 is 8. So one way I can get to that is doing 2 double bonds. And oxygen, I know, needs 2, but can definitely give 2. So I'm going to do a double bond here with oxygen and here with oxygen. And suddenly I have a stable molecule. Carbon needs 4. It gets 2 from oxygen, and it gets 2 from oxygen, bringing it to 8. Each oxygen starts off with 1, 2, 3, 4, 5, 6. It needs 2. And it gets 2 from carbon and 2 from carbon. We're sharing those covalently bonded molecules. And here's what my stable molecule of CO2 looks like. But I also can go in and make a totally different molecule. I'm going to do a triple bond of carbon to nitrogen. But then I need one more molecule, so I'm going to add that single bond to carbon, put a hydrogen here, and I'm going to do 2D to 3D. And again, notice the number of lines going into carbon are the same. 1, 2, 3, 4. 1, 2, 3, 4. Carbon is always going to need 4 bonds, 4 lines going into it to make it a stable molecule. Just like nitrogen is always going to need 3, but those 3 bonds for nitrogen could be 3 single bonds with hydrogen. Maybe we're going to make some ammonia. Or it could be something like the acid that I made over here. Ooh, and notice I just introduced a totally different thing by putting that line there. So be sure to space your molecules out. Let me know if you have any questions. I hope this video has sound and it was useful for you, and I will see you soon.